when they're averaging those judges' scores, what they'll do is throw out the high and low judge and use the 5 remaining or something like that, because that way, hopefully, the repeats of like the Winter Olympics from '02 won't happen again. You know, things like that. Okay! Let's raise our hands and show me with fingers how many times it took you 2 flips to get a repeat. So show me with fingers how many times it took 2 flips to get a repeat. Then hold hands up with fingers, and I'll go around and I'll count. I'll go around and I'll count. We got 5, 9, plus 7 is 16, 19, 22, 28, 31, 36, 40, 52, 58, 64, this is texting me in the first thing in the morning, 71, 78, 83, 91, 96. Carry the 1 rule. Carry the 1, damn it. 96. Holy Lord. All right, raise your hands for the remainder. Raise your hands for the remainder. All right. So this is the 3s, obviously.
I know.
14. 7 is 21.
6.
That was okay. I almost had that. 23, 27, 37, 44, 49, plus 5. Why can't I do this in my head? 53. Sumi, why didn't you got it? I didn't get you. 53, 60, 8, 71, 74, 79, 81, 86. All right. So we're short some trials. That's okay. That's okay. We're short some trials.
You dropped. There was 1 more.
Well, still, well, I was expecting 250 trials for 25 people doing it 10 times each. So whatever. I'm assuming that I probably drop out of the other one as well. What a guess. I tend to add up things wrong. And if you all did it 10 times, that should add up to something ending in 0 while we're at it, right? So let's just pretend I added correctly and got at least the right ratio of 2s to 3s. Now, is this to be expected as far as a number of outcomes? Do you think this looks roughly what it's supposed to look like? I'm going to get some of these off the board. Not that they're not beautiful. They are beautiful, but I want to make sure we tie it together. What do you think? Yeah. It ties kind of what Christina said. I asked for a vote as what it should be, how many and how many, and Christina said 125, 125. That implies to me that she thought there should have been the same number of 2s as there were 3s. We okay with that? People believe in that? Jessica was like, yeah, I believe that too. Why did you believe that, Christina? If you don't mind me asking, it was just a gut hunch.
Yeah.
It's a gut hunch. Just same thing, kind of a hunch.
Yeah.
We can actually prove it mathematically why it has to be. Believe it or not. Using a tree diagram. Now, your next project is not due till next week. But the point of that is to help you analyze situations like this and look at outcomes. And it seems kind of stupid to look at things like this, but it also helps you analyze things like performance of sports teams in World Series and things like that, or your favorite soccer team, or, well, actually probably watch basketball and stuff like normal Americans, something like that. But if you have a coin flip, right? Suppose you're flipping coins. On the first flip, it could go heads or tails, right? It could go heads or tails. If you flip again, it could also go heads or tails.
Right.
Now, all of these branches, and this is I'm jumping ahead of ourselves a little bit. This is your next project, just kind of to break down these tree diagrams. If you look at the result right now, there are 4 outcomes for flipping a coin twice. Heads, 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 tails, tails, heads, and tails, tails. It's just a very logical way of showing you what the outcomes are. In half of those results, you got your repeat right off the bat, didn't you? You got heads, heads, and you got tails, tails. That's half of the results. In the other half of the results, you're going to get your repeat on the next one, aren't you? So in half of the results, you're done at 2. In the other half of the results, you're going to be done at 3. So it makes perfect sense, I think, hopefully it makes sense logically to you guys, that the frequency of occurrence of these should be relatively equal. There should have been just as many Ziva ending in 2 as ending in 3. Is that fair? Now here's a question. I want to bring some statistics into this too. On average, I just made average a 5-syllable word. On average, how many flips would it take until you saw a repeat? On average. On average. I got to vote for 2.5. How can you have 2.5? Does it make you feel a little bit weird?
Yeah.
But guess what? It is 2.5. It has to be 2.5 because half the time you get 2 and half the time you get 3. Halfway between is 2.5. You've heard, on average, there are 2.5 children per family in America.
Right.
Right? Does anybody get squirreled out when they think of that? No! Remember what Michael said earlier? He looked over there and he said, oh, there's a 3 to 7 there and a 7 to 3 there. That washes out the 5 and 5. It's the same thing. When you have an average of 2.5 children per family, it means that that family has 3, that family has 2, that family has 4, that family has 1. There are just as many families with 4 as there are with 1. There are just as many families with 3 as there are with 2. There are just as many with 0 as there are with 5. Now, I may be getting overly simplistic, because that rules out the chance of having 6 and 7 and 8 kids in a family, which do exist.
Or 19.
Or 19. That happens too. That would definitely be called an outlier, I would hope, I think, maybe.
Yeah.
But the idea is you can balance those, and that's what 243 is all about, is getting farther and further away from that idea of pure balance. But the idea of it is balance. Yeah, the average of this should be around 2.5. Let's learn how to take what's called a weighted average. A weighted average. So we're going to I want to know, what is the average number of flips until that repeat? Now, remember how we did empirical and theoretical last week? Where we guessed at the formula and then we did the formula using technology to figure out, and we got pretty close to the same results. The empirical is going to be gotten from our data. Let's do the theoretical first, because you already did it for us, Amy. It was beautiful, thank you, by the way. The theoretical average is, talk it through with me. Half the time you get heads, half the time it takes 2, half the time it takes 3. Therefore, on average, it's going to take 2.5 times. If half the time it takes 2 and half the time it takes 3. So half the time it takes 2, half the time it takes 3, that ends up being 2.5. Nothing wrong with thinking that way. That's like saying, if you flip a coin 1 time, what's the average number of heads you get on a single flip of a coin? Well, you know the answer. You told me when you first walked in here. What's the average number of heads on one flip of a coin? A half, right? You told me that. It's 0.5. It's 1/2 of a head and 1/2 of a tail. When I go to the store to buy that baby chicken that they tell me is a girl, I know on average she's only 0.9 girl because she's 0.1 boy, right? Now you have to make it realistic, you have to apply it to more than one bird. To make it, I shouldn't say realistic, to make it meaningful. Like to say that there are 2.5 kids per average in America, it might make just stomach kind of feel kind of weird. All that means is there are 25 kids per 10 families, or 250 kids per 100 families, or 2,500 kids per 1,000 families. Make it bigger if it makes the average easier to you. Does that make sense? Hopefully. Good. All right, so that's the theoretical. What I want to teach you guys how to do right now is something called a weighted mean, which is something that every college student should walk out of college knowing how to do. It helps you pick a life insurance policy or a health insurance policy, helps you understand your car insurance, helps you understand when you should play Keno because they screwed up on the machines, and if they actually are paying out with more regularity, how to take advantage of that. There's all kinds of reasons why it's good. It's how do you understand that craps is going to beat you before you beat craps if you keep playing. How many of you ever watched that show, Deal or No Deal, with Howie Mandel? You ever watch that show? I can't anymore. It gives me agita. But have you ever heard people that are playing that show go, just keep going. Don't take the deal. Keep going. No, idiot, take the deal. Because if you keep going, statistics says you're going to walk away with 5 cents.
Yeah.
We actually analyzed that in this class a few terms ago, and we figured out when you should stop playing on average. It's all an average. That's the kicker. There's always the outlier. There's always the guy from the president, Philip Morris, going, I smoke 3 packs a day and I live to be 85. Yes, and we call you an outlier. The average doesn't apply to that, and that doesn't apply to the average. But so when you talk about averages, like 2.5 for example, that doesn't describe something that actually happens in any one trial, but it describes the typical occurrence. So let's do the empirical now. Empirical average number of flips until a repeat. All right. So here's the empirical. Gesundheit. It's also called a weighted average. How many of you have heard the phrase weighted average before? Weighted average. Oh, good, good. Weighted, about 10 of you. That's more than I was hoping. I was going to guess maybe 2 or 3. So that's good. That, like,
everybody would have, because
For a
you mentioned
GPA.
it before.
Yeah.
oh, so before this class, I'm sorry, before this class, how many of you heard the term weighted average? That's still more than I was hoping. Good, good. Yay. Yay for small things. Good. I have talked about it quite a bit because we've been using it here and there as we go through. So the idea of a weighted average is, well, actually, how do you calculate an average? I know, Brittany, you told me how to do this before, I remember. I asked about 3 weeks ago. I said, how do you calculate an average? You told me.
You add them all up and then divide however many.
You add them all up and you divide by how many there are, right?
Right.
So in order to average these 2s and 3s, you'd have to add them all up. Don't write this down. You'd have to add 2 96 times. And then you'd have to add 3 86 times. And then divide by, what is that, 182? I'm sure I added that right. Please don't do that. This is why we invented multiplication. What's the same as adding 2 96 times? 2 times 96! Thank you! This is called the weight of the data. 2 is weighted 96 times. Yes. Fair with me so far? Good? And then don't do 3 added together 86 times, please. Good God. Do 86 times 3. Yes. The weight of 3 is 86. It's the same thing you do when you calculate your GPA. This class carries a weight of 4. HHP 185 carries a weight of 1. This class counts 4 times as much. If you multiply by 4, we're HHP multiplied by 1. Whereas your science class multiplied by 5. Good. And then the sum of the credits underneath is still 182. Who's got the calculation for me? I'll do it. 96 times 2 plus, I'll put this on the board so you can see me doing it if you want, plus 86 times 3 divided by 182. That's pretty damn close to 2.5, isn't it?
Yeah.
Which is about 2.5. It's damn close, huh? Pretty damn close, 2.5. Now, some of you might think to yourself, Rule. Why? I love, by the way, some of you email me Rule. I love that. A lot of you call me Sean, and I love that you call me Sean. Please do. You don't have to call me Professor Rule. It's way too formal. I love those of you that call me Rule, though. Hey, Rule. Makes me happy. Appreciate it. It's small things.
Generational
It's a
thing.
small things. I know it is. It's a small things sometimes. I'm also from the East Coast and I'm Italian. Rule. Hey. Why would we need to do this empirically if we knew what the answer was theoretically? Some of you are thinking that, right? Hopefully you're thinking that. Like, we knew what the answer was going to be. Christina already told us. We're going to have just as many 2s as 3s, so that means it should be halfway between. It's a great question, right? Why would you do it empirically if you can do it theoretically? Anybody thinking that? Maybe you're thinking of it now. And the answer is quite simple. Very often, you don't know what the answer is, or you don't know the fractions you should use. It goes back to our discussion before. When I asked you, what does it mean to have 50% probability? Well, you guys can figure out what it means right here. It means you're going to have just as many times as 2s as 3s. But how would I estimate the chance of me getting a flat tire when I ride home today from work? What would you say that probability was? Me getting a flat tire when I ride home from work today. What would you consider that probability to be? So it's 50-50. It's 50-50, because I either do or I don't. Now, why no? Why no, Tim? Why no? Historically, data speaking, I have gotten about a dozen flat tires in the 11 years I've been riding my bike here.
So you have to prove how many times you've ridden your bike.
So now, I ride every day. Every day. So we'll go with work days for 180. We'll call it work days and make it simple. We won't count the times I ride at the store. 180 work days. I've gotten about 12 flats over the course of about 11 years. Right? With me so far? With me so far? Would it change your... Actually, let's just stop there. I'm going to come back to a fun outlier that happened once. So here we are. What's the probability I'm going to get a flat when I go home today? Is it 50-50? Is it? I don't think it's 50-50. 0.066. How did you get it? Amy, tell me.
12 divided by 180?
12 divided by 180.
Did I do that right?
You did it right if I got 12 flats in one work year.
Right.
You do 180.
That would be correct, correct? because that would mean I got all 12 flats in 1 year of working, in which case I would have stopped at about
How many years?
About 11. I think it's my 11th year. Well, make it 10. Make the math easier, because I've been through a full 10 years. I haven't got any flats this year yet. We'll see how today. Sounds like wood, doesn't it? What do we got? What's 12 divided by 10 times 180 or 1800? I should do this in my head, but I can't. 0.00067?
Yeah.
Something like that?
A million sixes.
Oh, I got one extra zero.
0606.
Oh, there we go, 0606, good, good, good. So that makes more sense to me.
Yeah.
Roughly 6 in 1,000 trips. If I spread my flats out over the course evenly, it should be 6 in 1,000 trips. 6 in 1,000, which would be 1 in every, roughly, what is that, 200, or give or take. Roughly 1 a year.
Right.
Makes sense, right? Now, you gotta also take into consideration the one day I got 3 flats in 1 day.
Oh my God.
3 flats in 1 day. Now you gotta take that into consideration, which would definitely Marichelle be, and you should have heard the obscenities. Even by this guy's standards. If it wasn't for Ann Jenkins walking down the hill after my 3rd flat, which was a 4-inch nail that somehow pierced straight through my tire, not only ruining the tube, but the tire that 4-inch nail. Please cover your loads of yours,
Have you made anyone mad?
Please. Made anybody mad besides myself?
Anyone mad that day?
Besides myself? No. So, the idea is that it's hard to estimate that probability without knowing what? Without what? Now we got a good estimation, right? But what do we have to know? We had to get some data, right? With this one, we could reason through the likelihoods as we went. We could say, okay, logically I should have just as many 2s as 3s, correct? But with the bike flat thing, either do or you don't, but that doesn't mean it's 50-50, correct? It doesn't mean it's 50-50. That would mean I'm getting a flat pretty much every day, once a day, either going or coming from work. And because of random clumping, sometimes I get a flat every single time I get on the bike. And every time I get a flat, it feels like I have, like, son of a bitch, this just happened. Like, wait a minute, it happened like 8 months ago. So we got a good subjective bias has to go out of there too. So that's where it gets tricky. That's why you have to have empirical methods of dealing with data. Let's collect one more set of data. I doubt we can analyze it today because of time, but because you have your coins in front of you, let's stick with the coins and collect the data right now. What I want you to do this time